All right, today we are continuing section 9.5. I'm calling this day 1.5. It doesn't really matter. We're going to spend several days on this. There's a day 2 and a day 3. So 4 total days on this. I think today and tomorrow are going to be pretty similar though, because it's just a little challenging to get the hang of what we're doing today. So today we are going to add and subtract rational expressions. That's similar to yesterday, except yesterday we were always given a common denominator from the beginning. Today that's not always going to be the case. So we have to talk about how we're going to figure out what a common denominator is and where to go from there. On we go. For our warm-ups, we are asked to find the least common multiple of the two numbers. Now that is different from what we're used to finding, which would be a greatest common factor. When they say least common multiple, they mean multiples of these numbers. So multiples of 6 would be 6, 12, 18, and so on. Multiples of 10 would be things like what? 10, Good. 10, 20, 30, 40, and so on. We understand what it means when it says multiple? So we are looking for the least common one, the lowest multiple that would occur on both lists. 30, good. So 60 would be a multiple on both lists, but 30 is going to be the lowest multiple that occurs on both lists. So you don't necessarily have to write out both lists, but on some of them it might be helpful to do. Do we understand what we mean by least common multiple? Okay. So if we're talking about 11 and 17. 44. 17 I don't believe goes into 44.
32.
It's close, right? It seems like they're almost there, but it doesn't quite work out. I think this one might be a case where we're not going to get to it until we multiply them together. The reason I say that is because 17 and 11 are both prime numbers, which means they don't have any common factors, so I don't think they're going to have a common multiple until we multiply them together. When we multiply them together, what do we get? 187? So I'm pretty sure that's going to be the least common one. You could check, the multiples of 11 are pretty easy to find, right? 11, 22, 33, 44, even when we get up into the double digits. But I don't think any of them will also be multiples of 17 until we hit the 17th multiple of 11. Questions, concerns about that? Okay. Now on number 3, we definitely don't need to multiply them together to get a common multiple. Anybody find it? I think we can do a smaller one.
30.
No, we can't do 30 because what's the first list number on the list for 105? 105 is going to be the first number on that list, so it definitely can't be smaller than that. Oh. Okay. Well, we can change this to 150. So it still won't be... That actually makes it even easier. What did you say, Linnea? 150? Okay. Sorry, I thought you said 450. Yeah, so 150 would be it. Now, if it had been 105, then the least common multiple would have been...
101.
No. 210.
Oh, yeah.
So just... if this had been the example on your paper, on our list for 105, we would have had 105 and then 210, which 210, I hope you all know, would also be on the list for 30. So that would have been the one for those two numbers. Okay. Questions, concerns about the least common multiple idea? Okay. Make sure you know that it's never going to be a number that's smaller than one of your numbers. Okay, so let's move on to adding or subtracting. We know that we need not a GCF, a common denominator. In common denominators, it's best if we can find the least common multiple. That's why we just talked about it. So what is going to be the least common multiple of 19 and 38? I wouldn't multiply them together. It's going to be 38. 38 is going to be the smallest number that's a multiple of both of those.
So 19 times 2 equals 38.
19 times 2 equals 38. So we are going to now have our two fractions, both with a denominator of 38. We already mentioned we had to multiply 19 times 2 to get 38. If we do that on the denominator, we also need to do it on the numerator on the top. So 5 times 2 gives me 10. Did I have to change my second denominator? No. So do I need to change my other numerator?
No.
Nope. It's going to stay a 7. Now that we have a common denominator, we can go to our answer.
38. 1738.
Good. 17/38. We keep the same denominator and we add the numerators. Questions, concerns? All right, number 5, we need to find the least common multiple of 24 and 36.
Ours is 16.
Yours says 16?
Yeah.
Oh, okay. Well, at least we know now. 5 over 16?
Yeah.
All right. That's fine. We can make that work. So what do we think our least common multiple is, Logan?
48.
48. I would have to agree with you on that. So this time, we're going to have to change both of our denominators. So I know I want both of my denominators to be a 48. I'm still subtracting in the middle. So what did I have to do to 24?
2.
Multiply by 2. So I also need to multiply what else by 2? The numerator. 2 times 7 is 14. On my other denominator, I had to multiply by 3. So 5 times 3 is 15. 14 minus 15 is -1 over 48. Questions, concerns? Okay, so in general, this is the idea that we're going to have to use today. We're going to have to find common denominators and then change our numerators accordingly before we can add or subtract. All right, finding least common multiples. Sometimes it's going to be a little bit tricky, especially when we're dealing with rational expressions, not just numbers. So step 1, find the prime factors of each expression. What that boils down to is factor. We're going to have to factor first. You want to highlight, put a box around the word factor, or write it off to the side. We need to factor. Write each prime factor the greatest number of times it appears in either expression and simplify. That step is going to make more sense when we can put it into practice. I might word it a little bit differently as we're talking through some problems. So let's talk about what this means. Find the least common multiple of 4x squared minus 36 and 6x squared plus 36x plus 54. Step 1 is just to factor. So anytime I factor, I should be looking for a GCF. What's my GCF here?
4.
A 4. 4 times what?
8. Oh, x squared minus 8.
Minus 9. Good. All right, now here is where it gets just a little bit tricky because it said that we needed prime factors. So on this next step, is 4 prime? No, what could I break 4 into? 2 times 2. So I need to do that. And I can still factor the x squared minus 9 into...
3.
Plus 3, x minus 3.
Good, x plus 3, x minus 3. That would be the prime factors of that first expression. Questions about it? Okay. Moving on to the other expression, I check for a GCF. What is it? 6. 6, and then what's left? Good. No, it's a plus sign. Okay. 6 is not prime. It can be written how?
3 and 3.
Not 3 and 3. What?
2 and 3.
3 and 2. Okay, sorry. I kept hearing like 2 and 2 and 3 and 3. I couldn't hear the 2 and 3 and all that. Okay. But we can also factor what's in the parentheses.
3, no, x plus 3,
X plus 3. X plus what?
3.
3. Okay. So then if we go back up to those steps that we wrote for step 2. Write each prime factor the greatest number of times it appears in either expression. So just collectively, we're going to write it the greatest number of time it appears in either expression. So one of the factors that we have is a 2. How many times does 2 appear on the left side?
2.
Twice. How many times on the right side?
1.
What's greater?
2.
2 times. So we're going to write it 2 times. 2 times 2. Another factor that we see is
3.
a 3. What's the greatest number of times we see that in either one of these?
3.
What?
3.
Once. It's only written here 1 time.
1, 2, 3.
These do not count. These are binomials. They're stuck together. They are not the same as just a plain old 3. So it only appears 1 time. Once is the greatest time we can write it down. What's another factor? What?
X plus 3.
X plus 3. What's the greatest number of times that factor appears? Twice. X plus 3.
Wait. 3.
X.
X plus 3, X plus 3, X plus 3.
You gotta write the greatest.
The greatest number. So it occurs how many times here? Twice. How many times here?
Oh.
How many times does it occur here?
1.
Once. So the greater would be the 2 times.
Oh.
And then an x minus 3. And then we would have to multiply all of that back together to get our least common multiple. Yes. Now, I'm going to show you a slightly different way of going about it when we move on to our examples. But this is how we would follow those 2 steps. I think this will make a little bit more sense when we get later on in our examples. Yeah, we know that this would be a 12 out here. When we multiply these together, it really isn't that bad. We'd have x plus 3. Back here, these are the difference multiply to be the difference of squares, x squared minus 9. And then the only thing you'd have left to do would be to double distribute these two parentheses. So really it's not that bad if you do have to multiply them together. We won't finish all of that on this problem just at this exact moment in time. We might have to add that step in later.
Okay.
Let's try that whole process one more time before we move on. So the first thing we have to do to both of those is
Break it down.
what word do we use to call that?
Factor.
Factor it. We need to factor everything. What's the first thing I could factor from 3x squared minus 9 minus 30? 3. What's left when I factor out a 3?
X squared minus 3x minus 2.
Good. And what we have left in parentheses there can factor more.
Five and two.
What are my signs?
Greater than negative?
Nope.
I know, I meant.
X minus 5.
Good.
X plus 2.
Good. And then we're done factoring that one. On the other one, what can I factor?
6.
6. What's left?
X plus 5.
X plus 5. Okay, and then on this one, we can't really factor what's in the parentheses more, but 6 is not prime, so how should I write it?
3 times
2 times 3, 3 times 2, whichever way you want to go about it. Now this one is a little bit different from our last one. So we want to write each factor the greatest number of times it appears in either expression.
3.
So let's start with our smallest, just plain old number, 2. What's the most times it appears?
1.
Once. So we write it down once. 3. What's the most times it appears?
1.
Once. What's another factor?
X minus 5.
How many times does it appear?
1.
Another factor?
X plus 2.
Sure. X plus 2 appears how many times?
1.
Once. And then our other factor?
X plus 5.
X plus 5 appears once as well.
Oh, I thought you did.
So this one is going to require just as much multiplying out pretty much as the last one. We'd have a 6. If we multiplied our difference of squares out, we'd have x squared minus 25. And then we would still have the x plus 2 to double distribute. The most important part to me right now is that you're able to factor these completely, including all the way down to the prime factors. That's going to be, to me, the most useful thing we need to do on the next one. The next type of problem. So let's move on and talk about adding and subtracting rational expressions, and then we'll do some examples. Find the least common denominator. It's the least common multiple of the denominators. That's why we were just talking about least common multiples. Rewrite fractions with a common denominator. Step 3, it's going to be to rewrite numerators accordingly. That step is not written up here. So that's step 3. You can either put multiply or rewrite. Three. Then we add or subtract. Finally, we will simplify. Anybody need more time on their blanks? Okay. First up, we are simplifying 1 over x squared plus 5x plus 4 plus 5x over 3x plus 3. So the very first thing I want to do is rewrite these with factored denominators. My numerators for right now are not going to change. I'm actually going to write this a little bit closer to the middle so that way I can write on either side of it if I need to. Plus 5x over. Okay. I roughly set this up for us to factor it. What is my first denominator going to factor into? X plus 4, x plus 1. My other denominator?
3x plus 1.
Okay. If I'm wanting these denominators to match, I want them to have all the same factors the same number of times. Does that make sense? You need to have all the same factors the same number of times so that they would multiply out to be the same thing. So right now, what does our left denominator miss from what's over here?
3.
A 3. So on this side, I'm going to multiply that denominator by a 3. But if I multiply the denominator by a 3, I better also multiply the numerator or top by a 3. Now, what is our other denominator missing that the first one has?
X plus 4.
An x plus 4. But if I multiply that denominator by an x plus 4, I better also do that to the top, the numerator. This is kind of the same as writing each factor the greatest number of times that it appears in either one. It's going to end up being the same idea. So for my left fraction of my numerator, 3 times 1 is just 3. For now, we can just leave this as 3 times x plus 4 times x plus 1. Do not get excited and cancel out those 3's. You're just going to be undoing the work that we just did. We're not going to cancel anything out until the very end of the problem. Our goal right now is to be able to add these fractions. So our goal right now is not to cancel out. On our other one, we need to multiply 5x to this set of parentheses, which means we need to
Multiply.
distribute, multiply, yes.
5x squared
Mm-hmm.
plus 1x.
Good. 5x squared plus 20x over that same exact denominator. 5 times x plus 1 times x plus 4. Even though I wrote those in a different order, it's still all the same factors being multiplied together. If it makes you feel better to write them in the same order both times, that's fine. Now when we go to multiply this, is there anything that we're going to be able to combine like terms in my numerator? So we're adding this, so can we add 3 to a 5x squared or to a 20x and combine like terms? No. So for our answer, it's just going to be 5x squared plus 20x plus 3 over
3x plus 4, x plus 1.
yes, 3 times x plus 1 times x plus 4. And I'm fine with you leaving the denominator factored, at least for now. We should be checking to see if we could factor the top. Okay, we would have to factor that with bubbles, but I'm just going to ruin the surprise and tell you that we cannot factor the top.
That's not a surprise.
It's not a surprise? You already looked at it? Figured it out?
Yep.
What trick did you use to know that? I'm very
I
curious.
just knew it.
You just had a feeling. Okay, I'll go ahead and ruin the surprise. It's not going to work out for us to be able to factor it. which means this is our answer. So the big important part here, well, there are a couple of them. One of them, you got to be able to factor those denominators. We should be pretty strong with our factor skills by now. You have to be able to identify which factors each denominator needs in order for them to match perfectly, and multiply that factor to both the denominator and the numerator of that fraction. Charles.
So there's a trick in saying if you need to use the bone method,
Yes.
or if it's not going factor.
Yes. So, all right. On number 4. This is a subtraction problem. First thing I want to do is be able to factor those denominators. So if that means you want to do some scratch work off to the side, you can, or off to whatever side you want to, because there are a couple steps we need to factor this 5y squared minus 125. The first thing we could do is what?
Take out the 5.
Take out a 5. What would we be left with?
Y squared minus 25.
Okay, but then that can factor further.
Y plus 25 or 5. Y plus 5. Y minus 5.
Okay, we got a 5 out in front. We can't drop it off. That's the difference of two perfect squares. So y plus 5, y minus 5. Questions about factoring that first denominator? There's a big minus sign in the middle. 4 over, what can I factor out from my second denominator? 3 parentheses, y plus 5, good. What, if anything, is the first one missing that the second one has? A 3. What's the first one missing? The first one is missing a 3. All right, that's the only thing that this one has that the first one does not have. So we're going to multiply top and bottom by a 3. What is the second one missing that the first one has?
Y minus 5.
What else?
5.
A 5. This one's got a 5 and a y minus 5. This second one doesn't have either of those. So we have to multiply by 5 times y minus 5 on the top and the bottom. Questions, concerns about how we figured out what to multiply by? Okay, so we look at the denominator on the left and compare it to the one on the right. All the one that the right one has is a y plus 5, which this one already has, so they're already even in that regard. But this one on the right also has a 3. This one on the left doesn't have a 3, so he says, I want that. Gimme. So we give him a 3. Now this one feels left out because this one is missing a 5, and it's also missing a y minus 5. So imagine it's like 2 siblings getting gifts from their parents, and you got to keep it even. They both want to have exactly the same thing on the denominator. So if one of them's missing something that the other one has, you got to make sure you give it to them. If you like the least common multiple thing of write every factor the greatest number of times, to me, I think that gets confusing. I like to just look at them and say, what is it missing that the other one has? Okay, that's what I need to give it. Charles?
So we have to multiply 3 times 7, or it would be 3 plus 7.
Nope, it's multiply. So what is 3 times 7y? 21y over. Now, I would go ahead and multiply the 3 and the 5 together and get a 15, but I would leave the binomial factors in their parentheses. Minus. Now, again, you might want to do a little scratch work on this off to the side. If we multiply the 4 times the 5, what does that give us? 20. Let me make a little more space for myself.
4y.
So we have 20, but then there's still the parentheses of the y minus 5.
24y minus 20.
No.
Well, we already multiplied the 4 and the 5. That's how we got the 20.
4y.
4y minus 25.
From that, we get
21 minus 100.
20y minus 100 over that same denominator, 15 times y plus 5 times y minus 5. We distributed the 20 into the y and to the minus 5. If you distributed the 5 first, and you got 5y minus 25, then you still have to multiply and distribute in a 4. So that 25 would still turn into 100 later. Now on this we have to be careful. We have a common denominator now, that's nice. But yesterday, what did we have to watch out for when we were subtracting?
The negative.
Oh, the negative, change that to a 100 positive.
Good. So we are subtracting both the 20y and the minus 100. So I'm not going to require you to write out a whole nother step, but you might want to put that in parentheses so that you remember we kind of have to distribute the negative in. So 21y minus 20y would be what?
Y.
1y. And Jacob already said the 100 has to turn positive. And of course our denominator is staying the same. Nothing's going to cancel out. So that is the answer. What questions do we have at the moment? Okay.